Goal is to solve the triangle. I have lengths of all three sides. I'm going to need all three angles. Definitely can't use the law of sines here because I don't know any of the angles and I don't have an opposite angle and side pair to use. So law of cosines it is. We have three sides and you can pick any one of them. If I start out with this side information, I'm going to start with the biggest angle, which is opposite the longest side. I'm going to do that every time. The reason for that is cosine values are positive for acute angles and negative for obtuse angles. So the law of cosines will distinguish between an acute angle and an obtuse one. Sine values, on the other hand, if I get down to using the law of sines after a minute here, sine values are positive for acute angles and positive for obtuse angles. So if there's an obtuse angle, the law of sines will not find it, but the law of cosines will. So I'm going to pick this biggest side. I did draw my triangle as obtuse, but I don't know that yet. Maybe it's obtuse, maybe it's not. But either way, the biggest angle is definitely opposite the longest side. That's how triangles work. So I'm going to start out with looking for angle C. Here we go. Here's the version of the law of cosines that I want. Side C squared is the other two sides squared minus, and we'll have 2AB times the cosine of angle C. Let's fill in what we know, which will be side lengths. C squared equals A squared plus B squared minus 2AB cosine C. I'm looking for C. Order of operations becomes important here. So I'm going to do 49, 7 squared, minus 3 squared, minus 5 squared. And then I got negative 2 times 3 times 5, so it's like negative 30. Be careful. I'm not adding 30. This is not 30. This is 30 cosine C. Trying to solve for C. The next thing I'm going to do is divide by negative 30. Let's see. 49 minus 9 is 40. Minus 25 is 15. And I'm dividing by negative 30. And that's cosine C. Well, I don't want the cosine of C. I want actual C. So I'm going to use the inverse of the cosine function, the arc cosine. I know that because it's in a triangle, angle C is either in quadrant 1 or in quadrant 2, which is the range of the arc cosine function, conveniently. So the arc cosine of the cosine of C will just be C, like I want. So I have the arc cosine of negative a half is C. Oh, I know that one. That's a unit circle one. That's pi over 3 in quadrant 2. But we're in degrees because it's the law of cosine. So 120 degrees for the measure of angle C. 1 down, 2 to go. Now I can use the law of sines. And I'm going to. You could do the law of cosines again if you'd rather, if you'd like it better or whatever. But generally speaking, the law of sines, there's a little bit less to it. So there is, in fact, an obtuse angle. I found it. There's not another obtuse angle because that wouldn't fit into a triangle, so I don't have to worry about that. So pick your favorite, A or B. I'm going to find A next. So now I have sine of that 120 degree angle I just found over its opposite side is equal to the sine of angle A over its opposite side. And this is standard issue law of sines here. I'm going to multiply and then use the arc sine function to find angle A. angle A. Looks like is 21.79 degrees. And for the third angle, we can do that by subtraction. Here it goes. That'll be B, 180 minus the other two. And we get for angle B, 38.21 degrees. And we did it. We found all three angles for this triangle.